So calculus is the mathematics of change. It describes things that are constantly changing. For example, in an algebra class, you might look at a car that accelerates from 0 to 60 miles an hour over 7 seconds and say, well, what was the average speed? What was the average velocity? And you would do that in an algebra course. But in a calculus course, you'd say, okay, but what was the exact velocity after 5.2 seconds? We can look at what's called instantaneous change. Again, calculus is the mathematics of change, things that are constantly changing. That is one aspect. Another aspect of calculus finds area under curved surfaces. So you could think of engineering applications, but more often you're looking at, say, economic scales where you have, dollars made per hour. Well, of course, it's constantly changing in a business setting, but you could find the area under the curve actually then finds you the profit. And so you can't do that outside of geometry if it's curved. And geometry, everything has to be straight lines. But in calculus, we can actually find the area under curve. So it's the mathematics of things that are constantly changing. The course description is here. I'm not going to read word for word, but we cover things like limits. That'll be something new that describes, well, what happens as things go off to infinity. That's something that is not usually considered in a pre-calculus course, but it is considered very heavily in a calculus course. Some of these other words, the derivative, that's the thing that's describing how fast, like the acceleration example I was talking about. Anti-differentiation, which that's the finding the area under the curve kind of thing. So there's a lot of, I know, vocabulary in here that you really wouldn't understand without taking the course, but this does describe it a little bit. There's a lot of algebra involved. You do have to be fluent with your algebra, so there's a lot of that. But that, in short, is what calculus is like.